This is the video for Mod 7, Lesson 1, Reciprocal Functions. In this section, we have goals of identifying our 6 trigonometric ratios for a given angle. So we've already learned 3, sine, cosine, and tangent. Today we're going to look at the next 3, which are the reciprocal functions. And then we're also going to evaluate an angle using trigonometric ratios. So our reciprocal functions are really taking our original 3 functions of sine, cosine, and tangent, and just simply taking the reciprocal or flipping the fraction. So our 3 reciprocal functions are cosecant, which is your hypotenuse over your opposite, so that's going to be the reciprocal of sine. We have secant, which is hypotenuse over adjacent, so that's the reciprocal of cosine. And then the last one is cotangent. And that one is adjacent over opposite, which is the reciprocal of tangent. And this should only say one tangent right here. So when we look at this, you want to think about it almost as pairs. So if you know sine, cosine, and tangent, you just have to know the reciprocal. So sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Our first example is just going to be finding our 6 trig ratios. So the first 3 are very similar to what we already did in the last mod. So we call our angle theta. That's just a variable we like to use for an angle. And we're going to label everything in relation to that angle like we did before. So our hypotenuse is 13. That's across from the right angle. Again, if I trace the angle, the leg that forms the angle is our adjacent, and then our 12 would be our opposite. So when we write our trig ratio, again, we're still using SOHCAHTOA. Our sine is opposite over hypotenuse, so that would be 12 over 13. For cosine, our cosine is 5 over 13. And then our tangent is opposite over adjacent, which is 12 over 5. So that part isn't anything new. The only thing we're adding now is our reciprocal function. So sine, the reciprocal is cosecant, so that would be 13 over 12. Cosine, the reciprocal would be secant, so that's 13 over 5. And tangent, the reciprocal would be cotangent, which is 5 over 12. And those would be your 6 trig ratios. In the next example, it's the same concept. The only thing is we're missing one of our sides, right? You can see we have root 7, we have 3. I need to find what that third side before I can answer what those ratios are. And we're going to use what we learned last unit, and we're still going to do Pythagorean theorem because I have 2 of my 3 sides. I can use Pythagorean theorem. So when we go ahead and do this, our hypotenuse goes on a side by itself. And so we have root 7 squared plus 3 squared is equal to x squared. We're going to go ahead and simplify that. So the square root of 7 squared is just 7. 3 squared is 9. We're going to get 16. And then when we take the square root, we're going to get 4. So that hypotenuse is going to be 4. And then we're just going to do the same thing as last time. I'm going to label the adjacent and the opposite. So this is my adjacent. This is my opposite. And we're going to do the same concept of doing sine, cosine, and tangent, and just making sure that we're rationalizing at the very end, and then taking the reciprocal to get our reciprocal functions. So sine would be opposite over again, we're doing SOHCAHTOA. So sine is opposite over hypotenuse, which is 3 over 4. So cosecant would be 4 over 3. Cosine would be root 7 over 4. So secant would be 4 over root 7. And then we'll check at the end if we need to rationalize. And then finally, the tangent would be 3 over radical 7. And then the reciprocal will be radical 7 over 3. I then suggest after you do all that, doing the rationalizing, because that way you don't want to rationalize and then when you take a reciprocal you have to rationalize again. So I can see I have to rationalize tangent and the secant. So for tangent I can multiply top and bottom by radical 7. So we would get 3 radical 7 over 7. And then secant I have to rationalize also by radical 7. So 3 radical 7 over 7. And those would be your final answers for those two, and then those would be all 6 of your trig ratios. The next topic we're going to look at is evaluating angles, and specifically using our special right triangles. So if we think of our special right triangles, we know sine, cosine, and tangent. We can derive from that. If I have my 30, 60, 90, we typically have been using our ratio of 2k, k radical 3, and k. I can leave it like that. I can put a value in for k if I really want to, but we're looking to find the sine of 30 degrees. So it doesn't matter what type of angle we're looking at, or what the side lengths are, they're going to reduce to be the same answer. So you can use the k's. You can also rewrite it without the k's and just leave the ratios there. So I could make this a 2, a 60, a 30. This is like a 1 in front and a radical 3. So with these problems, when we're doing the ratio, you can use the k's if you like. They're just going to cancel out. So if you'd rather do it without the k's in there, that's fine too. And I'm going to find the sine of 30 degrees. So sine would be my opposite over my hypotenuse. So sine of 30 is going to be 1 over 2. And again, typically with these, we don't want to just put them in our calculator. We would like exact answers for these ones. If I had kept the k's just to show you, if I did sine of 30 and did it with the k's involved, you would have had 1k over 2k, which still would have been 1/2. So you would have gotten the same answer either way. For the next two, they're kind of the same concept. So with the 45, 45, 90, because this is tangent of 45, I had it as k root 2. If you don't want to write the k's and just want to write the coefficients in front, you can do that. Like we saw in the last example, both will get you the same exact answer. So we're looking for tangent of 45 degrees. I can choose any 45 degrees I want. They both are going to get me the same answer. So tangent of 45 we see is 1 over 1, or 1k over 1k, which would just be 1. So tangent of 45 would just be 1. For the last one, we have cotangent. So you can do this a couple of different ways. So we have cotangent of 60 degrees. I'm going to do 60 degrees, my 30, 60, 90. And I'm just going to write without the k's. But again, if you want to put the k there, you'll get the same thing. And if we get stuck on what cotangent is, really what we can do is we can find tangent and just flip the problem when we're done. So tangent of 60, you can see that's my opposite, my adjacent. That's going to be root 3 over 1. So then we know cotangent is the reciprocal of that. And then at the very end, I'm going to see that I have to rationalize my answer. So I'm going to multiply top and bottom by radical 3. And we would get radical 3 over 3. And so that would be my final answer for cotangent of 60 would be radical 3 over 3. If you have questions from the notes, please make sure you're asking questions in class, during T-Bolt time, or in the center. You do need to complete the U-tries to receive full points for these video notes. So when these are checked in class, you do need to make sure you have your U-tries completed to receive full points. So again, the remaining problems from this section need to be completed, even if they're not perfect. We need to see that you're trying the steps out before you come to class so you're ready to ask questions. All right, thank you very much and have a great rest of the day.